Okay, picking up where we left off, as we were finding c sub 8, we found it was the opposite of c sub 4 over 56. Well, that's negative 1 over 56 times c4. But look at c4 here. That's the opposite of c sub 0 all over 12. Well, what is 56 times 12? I believe that's 672. Well, let's do maybe just one more. Let's let k equal 7. And as we let k equal 7 come up here, you can see, of course, we're going to find c sub 9. This would be the opposite of c sub 5. Down below, 7 plus 2 is 9. And 9 times an 8, actually. 9 times 8 is going to be 72. So we'd get negative 1 over 72. But what is c sub 5? Well, look up above. C sub 5 would be opposite C1 time over 20, sorry. This is C sub 1 all over, I believe that's 1,440. Well, what we're going to do, just like we did in our last setup, is if we looked at this expansion, n equals 0 to infinity of C sub n x to the n, this of course would become c sub 0 plus c sub 1 x plus c sub 2 x squared plus c sub 3 x cubed. And we're going to continue to work this out. C sub 4x to the 4th, c sub 5x to the 5th. I'm writing a whole bunch of these out. You can see we're getting quite a bit here. And the fact is, just by looking at what we've written down on this column, I think it becomes very evident that some of these terms are going to involve c sub 0, some of them are going to involve c sub 1. We can say, what about c sub 2? Well, c sub 2 was 0, wasn't it? So was c sub 3. Actually, so is c sub 6, and so is c sub 7. But as we're continuing to work this out, c sub 4 was negative c sub 0 all over 12. And that's what we have in front of x to the 4th. For c sub 5, we had negative c1 all over 20. That's x to the 5th. Let's see, for c sub 8, we had plus c sub 0 all over 672, x to the 8th. And then we had plus for c9, that's c1 all over 1,440, x to the 9th. And my goodness, as we're looking at that, maybe you don't see an obvious pattern. But there are a couple of ways that we can generate this. And what the author suggests is, and of course you can just see what's happening, we could say, what if we let c sub 0 equal 1 and c sub 1 equals 0? If that were the case, our first series, totally dependent on c sub 0, would be a 1 minus 1/12 x to the 4th plus 1 over 672 x to the 8th. And we'd continue on. Looks like we have powers of, well, multiples of 4 for our exponents. We could also say, well, let's let c sub 0 equal 0 and let c sub 1 equal 1. Well, now we generate a second type of a series, in which case we'd have x minus 1/20 x to the 5th plus 1 over 1,440 x to the 9th, and this would continue on. And really what we could find then is here are our two solutions. Of course, we could say that y would equal c1 y1 plus c2 y2. We could have this combination of the two series, yielding a general solution. Okay, so in other words, if we were to look in the back of the book, you could see what the author might be writing for solutions. Combining these two together, just like so. Okay, so here are two linearly independent series solutions. We know that when we add them together, we're actually going to get those constants C1 multiplied in and C2 multiplied in as well. And combine them together, and you can pretty much see that that's an altered form of what was written up above when we were writing things out right here, really. Okay, well, best of luck to you. Next lesson that we're moving on to, we're going to be looking at 6.2.